Okay. So, hello everyone. My name is Magda. I'm a Scala developer at Software Mill, and today I would like to show you a small but very handy feature in Scala 3 called opaque types. So let's start by saying what kind of problem are we trying to solve. We are trying to have the perfect model. So when you get to the new project or when you're developing an existing one, you try to make sure that your case classes, your model is the perfect one using types and so on. So what does it mean, a perfect model? First of all, it has to be precise. So it has to be as close to reality and to your business requirements in the terms of types as possible. It needs to be readable so that when I'm new to the code, I see the code, I see the types, and I see what is expected of me to put in the instances of these classes or types. And if possible, it should prevent mistakes. So we have the type system, and the type system should guard us from inputting incorrect data. Ideally, it should make incorrect data impossible to have in our system. So that's why we have the type system. That's why we love it. So let's use it as much as possible. And in the world of Scala 2, we had a couple of tools to achieve that. The first one, very simple, just simple type aliases. Not much there, but just having the name of the thing that you are trying to model is pretty useful already. Then we had value classes. So that's something pretty common, I would say, and useful. It basically is a way to wrap your data, your type, into something that has a name, and you can expect, you can say that in this place you expect, for example, the age. And there are other things like, for example, the external library refined types, which allow you to specify your constraint even more closely, even more concretely, and even verify them in compile time. But this is an external library which you have to import to your project, not a feature of the language itself. And what do we have in Scala 3? We can use opaque types, or opaque type aliases as they are called, to solve this problem. So right now I will show you in a quick live demo how they look like, why they are called opaque, how to add API for them, both the object methods and the instance methods. And I will also show you how to use bounds and how they can be helpful. So we will be working here in the simple test case. And let's imagine a sample domain. Let's say we are in the library business. So that we have to model books. So let's start traditionally. We have a case class, book. Let's say it has a title, it has the number of pages, and it has a year when it was published. So right now, just plain types. And the way we would use it, we create a book. Let's say it's Pippi Longstocking because it's a great book. It was published in 2010. It has 350 pages. And then let's write a simple test saying that the pages should be 350. And let's check if the test is okay as we expect. No. What is wrong? 2010 was not equal to 350. So see, this is one of the problems that I'm talking about. Here, when we are using just plain integers, we can easily get distracted and confused and just input the year where we expect the number of pages and so on. So this is one of the problems we are trying to solve. How can we address that? Well, we can have traditional aliases. So let's say we have type pages, which is an int, and type year, which is also an int, and we can use it here. This is plain Scala 2 aliases. Here, nothing changes. We still can make the error. And how would you use the opaque types? So the new thing from Scala 3, you just have this opaque keyword. And this way you have defined your first opaque type. But right now, still nothing interesting happens, but just bear with me for a while. Normally, you would put your definition somewhere else. So let's move it to an object books, and we will move our domain definitions here. We have to import it. So let's just import everything from books. And what happens here? Now it says it has found, maybe let's just fix it to be sure that now we are expecting it to be correct, but still it says it has found an integer and it required pages. So this is the one of the key things where opaque types are different. And this is what it really means for them to be opaque. They are not transparent. So when you are here in the scope where the opaque type is defined, then for the compiler, pages is the same as integer. But when you are in a different place outside of the scope when it is defined, then for the compiler, pages is just pages. It doesn't know, it has no idea that it has an integer inside. So what can we do about that? If you are used to value classes, you would expect something like this. But here, you cannot do it. And this is another thing important about opaque types. They don't give you no API whatsoever out of the box. So you have to specify it yourself. So let's try to specify such an API. And for this, we will use traditional or just plain Scala 2 features. So let's say we want to have this kind of API. We'll provide a constructor in the companion object for the pages. So we just define a method taking an integer, returning pages, and the body of the method will just be the value. Because here we are inside the scope where the opaque type is defined. So where we expect pages, we can pass an integer, and this is fine. And let's do the same for year. It will be basically the same, returning the year and value, and we can use it here as well. Okay, so this is fine, but if you don't like this kind of API, you can also use, you can have this if you use the simple trick, let's say, of defining a method with that page. So again, let's take a value of integer, return pages, and this is the body of the method. And the same way you can have with year, taking the integer, returning year, and this is the body. So right now our API looks a bit better. And this is fine, but maybe we want to validate, because right now we still can, this is a bit better because right now you have explicit name pages set here. So it's not so easy to make a mistake, but still you can do it. For the compiler, this is still fine. And you will just know in the runtime that this is wrong. So maybe you want to provide smart constructors for that. This is something which you may already heard about, but this is just a method which before returning an object to you, returning an instance to you, it will validate whether you are trying to construct a correct instance. So let's provide such a constructor here. Now it will return an option of pages. It could also return, for example, an either, but for simplicity, let's just make it an option here. Let's say, what is the safe value of pages? Maybe just greater than 0. Then we return sum of value, else none. And similarly for the year, we return an option of year. And what's the safe value of the year? I think this is around the year when the Gutenberg's Bible was published, so this should be safe. And we cannot have anything from the future. So in this case, return the value, else none. And how do we use such smart constructors? we have an option, so we have to map it. So let's do it in a for comprehension. Let's say we have pages, save. Let's make a mistake, stupid mistake here, and the year. Maybe let it be correct. And let's check it. Let's write a test for it. Yeah, we want to yield something from this for comprehension actually. So another good book. And here we have to write pages because the compiler wouldn't accept years. And not pages, of course, but book. And then invalid should be none. Let's check it. Yeah, again, this we have to fix because this still is not correct for our test. And now the test has passed. So we can also write a similar test for the correct type. This will be valid. And let's have a good number of pages. Everything else is okay, so this should be defined. This is just a Scala test matcher to say that the option returned is not empty. And this is fine. So this way we can provide the smart constructors for it. So we've got a bit of the API already defined for the types, but sometimes this is not enough. Let's say we wanted to say, for example, books published to age, and we would like to say that we would like to convert the year of when it was published to the age. So here it should be, I think, 11, right? Should be 11. What if you wanted to have an API like that? So call a method actually on an instance, not on an object of this type. So for this, we can use another Scala free feature that we already heard about today, extension methods. So we can define them like that. An extension on the type year, and we call it to age. We want to take a parameter because we want to have age, then we want to know when is now. So we are taking local date and return an integer, just an integer with number of years. And the implementation is now years minus the year of publication. So right now, this is how we define instance methods to the opaque type. And let's just verify that it works. This thing here, we have to call it with local date of now. And it's indeed fine with that. So we've got all the API here. And this is the way you can do it. But let's also imagine that we have some legacy method defined not on our types, but on the general types. So here or integer. So we have a method which for a given year of publication, it returns whether the book should be taken for renovation or not. If it's old enough, it should be. And we would like to use it. So we would like to say legacy should be renovated and then say book published. And it should not be renovated because it's pretty new. Of course, we cannot do it because the compiler here is outside of the scope. It doesn't know that it's integer inside. But we know it's the integer inside, and we would like to use it. So what can we do about that? There's a nice thing called bounds, and we can say that this year is a subtype of integer. And this is the type bounds. You can have the upper and the lower bounds for opaque types. And what happens now is we have inherited the API of the upper bound, so the API of integer. So right now, anywhere when we expect the integer, like for this should be renovated method, we can pass our year type. And the compiler is happy about it. And the test should be happy about it as well. Yeah, it's cool. So This is the last thing that I wanted to show you. So we have seen the opaque types, we have seen the API for them, both the object methods and the instance methods, and you have seen how to use bounds if you are happy with getting the API from the upper type. So to sum up, this is a very cool feature, I think, of Scala 3. It's simple and clear in the sense that when you come into the code, you quite easily see what it's about. You don't have to go back to the documentation, read about it, and see what happens there. It's got no overhead, so this is a pretty important thing. Unlike value classes, which sometimes have to allocate some heap space and so on, for opaque types, this is not the case. They are very thin, and if performance is important in your project, then this is something you should have a look at. And they are opaque, so they allow you to enclose the internals where in the scope where you define the types, and outside of it, it can be opaque. But it is not also not for everybody, or maybe not for all projects. First of all, you don't have any API out of the box unless you use bounds, but sometimes it's not something you want to do. You don't want to inherit the whole API. It's erased on runtime. So in runtime, my types were just simply an integer. And that's why also those Scala test matchers were fine when they got 350 instead of my opaque type. You have no pattern magic on it, no unapply method. So this is something different than value classes. And you cannot override toString or equals, because these are not classes, these are types. So it's something to be aware of. But if you use it the right way, it's, I think, a nice tool to your toolbox, and it can be a way to make your domain model very clear and very precise. So a step closer to being perfect. If you'd like to read more, you can have a look at the official documentation of opaque types in Scala 3. There are some more details explained. And if you'd like to have a look at this demo code, there's a repository in my GitHub with all the steps. And if you've got any questions, now is the right time to ask. And if you have any feedback regarding the presentation, you can scan the QR code at the bottom.
Thank you so much, Magda. There is definitely a few questions in there. Can you see the Q&A section? Sorry.
Okay, I can open it.
Yep, there's quite a few. You've got a few questions in there.
Okay, so the first one: the opaques seem to be needing a lot more of boilerplate code. What are the benefits with regard to the value classes? So I think the main benefit, I would say, is the fact that they have no runtime overhead. So for value classes, as I mentioned, sometimes you have to have some space allocated on the heap, and sometimes when you construct a lot of them, it's not okay. The second one: how do you get the value from the opaque type? So this is something different than value classes. Maybe let's get back to the slides, because if you are used to value classes, then you say book pages dot value. But here you don't do it. It's shorter API, I would say, because you get the pages here, and if you want to have the integer, then you have to have some kind of conversion method, or you can use the bounds. Otherwise, you cannot get the value that is inside. Let's see the rest of the questions. I think upper bound does not make page being a subtype. It just delegates API. That's a good one. The way I understand it is I'm not sure. I would have to check it. That's a very concrete question. It does make you inherit the API, and it does allow you to pass the page everywhere an integer is expected. But I'm not sure if that's the full definition of being a subtype.
If I may interject something.
Yeah.
Yeah. So it really is important to remember that a subtype relation is a reflexive relation. So a string is a subtype of string as well in terms of Scala. So you just have to think in the terms of, this is not like a strictly a class that extends something, is just a marker for this type being of this type, right? Being the second contract. So essentially the answer to that question is kind of both. And this is this just comes out of the subtype relation.
Yeah. Okay. Thanks. So the last one, I think, or maybe not the last one. How would runtime erasure be a disadvantage because the opaque type is still an integer? For me, it was a disadvantage when I started to play around with that, because I would expect that if it is opaque, then it is opaque, and it just isn't this integer everywhere. But then when I tried out those Scala test matchers and so on, I saw that it in runtime it's actually treated as the integer underneath. So for me this was a bit confusing. Does it work with JSON and, for example, Circa? I think it would work. I haven't tried that, but I think it should work because it's thin and it's got this type erasure or runtime, so it should be treated when serializing as the type underneath. But I'm not 100% sure about that. That's something I would expect. Yeah, impact on JSON serialization, deserialization. So that's the same thing. And as an example, can you write conversion method to get value from opaque type? Yes, exactly. You could write the instance method, the conversion method, to get the value inside from underneath. And I think we've got all questions answered now.
Amazing. Thank you so much.
Thank you.
Magda.